This tutorial is on how to use the pyPincher2 software to control the pyPincher arm. Go to my GitHub repository and download pyPincher2, and then run the pypose file. Create a new project, and then create a new pose. By selecting that pose, you can then start to modify the simulator's position by rotating the control knobs. You can also zoom in, zoom out by the center mouse wheel, rotate vertically and horizontally, and move the model up and down with the right mouse button. There are two different IK simulators, the world and the tool. The only difference is the world only works in one quadrant and the tool works in all four quadrants. There is collision detection, and here it shows collision force fields. I use a simple sphere collision detector. Then you want to open the port after turning on all of the safeties, disable the torque on the robot, and you can set the limits, safety limits, and by each axis. So after you disable the torque, you can then rotate all the way from one limit to another, and then hit the set limits button to save the new safety limits, just like in this picture. Then you can set the high limit, set the low limit with the two buttons, and when you're done, press OK. You can also adjust the size of the collision fields for each axis. You can make them larger or smaller. These collision fields, if they come into contact with each other, they'll keep the robot from moving as long as the collision safeties are enabled. Here I enabled the collision detect, and as you can see, the robot stops before the spheres collide with each other. Between this collision detection and the servo limits, it's pretty safe, and I usually just set them when I turn it on, and I've never had it crash yet. Here you can just see the collision detection working, and you can set the radius of the sphere to anything you want in millimeters. Here it's just showing them off, and the collision detection still works. You can't go beyond a certain point. Most of the time when you're running the robot, you want the collision detection to be on and the safety limits to be on. That will ensure that the robot doesn't collide. You can also change the color of the robot to anything you want. There's an equation editor button which allows you to type in any equation that you want, as long as it follows Python NumPy format. And here I'm typing in the equation of a circle with an offset. After entering this, it will calculate all of the positions of the circle, giving the start interval, stop interval, and the step interval. So here I made it 2 pi, which is the size of the circle. And if you hit the run button, it will do one cycle, which it's doing here. And there was a collision on the big sphere on the base. It's a little bit bigger than it needs to be, so I'll reduce the size of that to 45, and then run it. and it looks good, no collisions. Here's after you press the live enable button, the robot following the path of the circle. By pressing the continuous run button, it will continuously run like this, and it'll just keep repeating over and over and over until you hit the stop or pause buttons. Like this. And you can hit the clear button to remove all of the pose editor and transition editor functions. And the equation editor, when you just open or push the button, comes preloaded with a helix like this one. Is just preloaded into the variables. Just for demonstration purposes, you can adjust the step interval of the helix to make it smoother, and that will give you more positions and transitions. Here's an example of a smoother helix. Here is an image I drew in Inkscape of a python. I just drew it with a mouse. It's not very good, but just to demonstrate the import object file. Then I imported the scalable vector graphics file into Blender and used Blender to export this as an object file with a list of vertexes. Then I used a little program just to basically measure the distance between all the points, and then the points that were a far distance away from each other is where I want the pen to lift up for drawing, and it would look like this. And that's the final vector file. And then this is the robot running through the actual tool path using the import object button. Here is the robot drawing it, and a still image of it, and then the final image after the robot drew it. These are some of the features of the pyPincher software. If you use this and you have any problems, let me know and I'll try and fix any bugs. Also stay tuned because I plan on adding a camera library to process images captured from a camera, and an oscilloscope library. Thanks for watching, and check out the README file for all the packages that you need to download to run the software.